Alright, so help us understand this.
Hey. Okay. Hey, hi Kika. We're basically going over notes, and yeah, that's it. And then we'll start making the presentation, so that next week we will do homework, check the homework, and if we get any of them wrong, we can correct it. But as far as like presentations, like our mock presentations, we're going to try to do those during lunch and learn. You guys okay with that? And have to sacrifice Foursquare in social time. Okay, so cool beans. You're about to begin. All right. So as you know, we've gone through page 642 with the definitions of hyperbola, foci, center, vertex, asymptote, transverse axis, conjugate axis. And then we talked about the formula to find the standard formula to find the hyperbola. Wait, is it to find the center or what? The hyperbola and the transverse. Yeah, it's a standard form of the equation of a hyperbola. So
this right here?
Yes, it's this. If you look on page 643, it is x squared over 8 squared minus y squared over b squared equals 1. And it literally beside it says by the Pythagorean theorem 6 squared minus 8 squared equals b squared, and that's on page 643. And then it says if the foci are on the y-axis, the equation is y squared divided by a squared minus x squared over b squared equals 1. So that's if the foci are on the y-axis, which means instead of the parabolas being this way, the parabolas are this way. So like instead of them facing each other like this, they're facing each other like that. That makes sense.
I'll draw it.
She doesn't have to show it.
Graph. And this is on the y-axis.
Okay, where's the equation?
That's on the y-axis.
Yeah, so that's the first equations I was talking about, like the x squared. Okay. Here, write the formula on there, Jacob. So that right there. So that's it. And then there's another one if the foci are on the. There's another right there. Okay. So this is if the foci are on the y-axis. So if they're flipped like this. Okay. If you have any questions about that, you can email Jennifer, me, or Jacob. Okay. And then here it has. I'm assuming that this table is pretty important.
So we need to talk about what the y and the a and the b and the x stand for in these equations.
What do you mean?
Well, we know
the variables.
We know that x and the y are going to be a point probably, and then the a and the b are sort of what the foci are.
Yeah. Okay. So remember that little chart with this right here. Hakika can't see that, but okay. So Hakika, if you look at this little picture at the bottom of 642, so this right here, you see A, there you'll have A and then you'll have B. So that's where you're getting this from. This is A and this is B. Okay, everybody got that? Mentally? Cool. I think I'm getting a lot better at taking notes through the book since I've been doing it for like the last 2 days. So I'm getting stuff more. Okay. Yeah. After we, well, I think we should look at the whole chapter first because we haven't even finished like going through the whole chapter.
I mean, like, 'cause she usually does, like, give us information and it doesn't.
Yeah, but that's for our lesson. But we need to make sure we understand first, so we need to like go through the whole.
I know, but I'm kind of good with understanding.
So like, what you're saying is you don't understand, or what?
I understand that.
So can we move on, then go back and do examples because we really do need to get through the rest of this chapter.
I agree.
We can always meet up on Friday. I think that's a break now.
I can.
I'm sorry. I don't think I can either.
Vacation.
I think it's supposed to be.
Alright, so the next section.
Okay, so wait, we didn't talk about this chart. Okay, on page 643, at the bottom of that page, there's a chart, and the column headings are standard form of the equation of a hyperbola, orientation, and description. And basically, it just tells you like the standard form for the equation, what it would look like, and then what the variables stand for. So it says x minus h squared over a squared minus y over minus y minus k squared over b squared equals 1.
What is that for?
Standard form of the equation of hyperbola.
So this is standard form for the foci.
That's the hyperbola.
Standard form for the equation of
What is this?
hyperbola. So how you would draw it, like if you wanted to plot this, I'm assuming, then this is how you would draw it. So you know how like you have an equation for a parabola, and it'll be a squared plus b. That's so ax squared plus bx plus c. And that's the equation for the hyperbola. Well, for a parabola. Well, here for the hyperbola, this is the equation. If the hyperbola is like this.
Right here.
Here.
That's using the Pythagorean theorem.
Well,
What's
no.
the difference between these two?
This one, Miss Lane said the Pythagorean theorem and all this is just explaining why this is true.
Okay.
But she also said that.
So what is this one?
Let me look at it. Let me read. Let's reading this one fundamental.
You said this was standard form, right?
No, this is standard form. Because it says it's standard form. Honestly, I have no clue. We have to ask. So,
Alright, so let's work on standard form right now.
So that x squared over, so that these equations right here. From the x to Jacob.
Someone.
I'm sorry. Okay. Okay. These are the equations that we're confused on. Because even though we just said it was standard form, that's wrong. It's not. The standard form are the ones in the table. So if you look at your table, those are their standard form.
So this is standard form.
No, this is standard form. We don't know what this is yet.
So what did you draw?
Oh, I just told her what was confusing. Okay, so I just told her like what we were confused about these two right here, what they're used for.
So standard form. Go ahead. Do that.
Okay. So, what do you mean? What do you want me to go through?
Just like explain it, whatever you need to do.
Okay, so you just plug in. Literally, you're plugging it in. So A, it says the center is HK. So that's where these two variables H and K come from. If you're looking at the table on page 643, so the is the point. The center is the point HK, and then the foci. Wait, that doesn't make sense because you're using.
You don't make sense, Dylan. This doesn't make sense.
What?
So this is standard form, so you just plug the stuff in, right? So what's H and K?
But no, but like here, they use H and K again here.
Those are just the really, like you find the center and you plug it into here. Like it's probably gonna give you the center and stuff. That's what HK is.
Maybe this looks like points.
Yeah.
X and Y.
That is the center is a point, and the foci is a point, but the foci shouldn't be the same point as.
It's not. It's plus or minus C.
Oh.
This is
That's
A
what that meant.
plus or minus A.
Okay, my bad. Okay, so.
So what is C? We know that H is the point of the center, and K is the point of the center. What is C and A? We know C is A is, but we don't know C is.
Well, I'm coming back to here.
So what is C right here?
C is from here to the Oh, the
Foci.
foci.
Focus. Yeah. So from the center to the focus.
And then A is from the center to the
vertices. And then C
Gotcha.
is.
So when it says plus or minus, do they mean do both or?
Yeah.
plus or minus, yeah. So I guess there's two solutions.
Oh, duh, because there's two foci.
Yeah, and remember the center is directly in between them, so it'd be like 0.
So,
Make sure I got that.
Okay, so Jacob, if you would like to explain it, or Jennifer,
I'm not extremely understanding.
Explain this or this.
Both go together.
Alright. So Hakika, whenever you're looking.
You might want to turn the computer towards you.
Alright, so whenever you're looking at the graph, the very first in the orientation column, you've got the you see where the vertex is and you see where the center is. So first you want to find the center, because that will give you your H and K value, as Marcus did.
No, it's just the way you're writing. Oh. Okay, alright. I can get it.
Alright, so your center will be the point
HK.
HK. Well, we gotta know what H and K are.
H and K is right here. If that's the center.
Okay, it doesn't give us any numbers.
So it goes back to if you know the definition. So this is the center, and then it's saying to find your foci, you do H. So the X from your center, and then
yeah,
plus,
it just didn't give you any numbers. That's what I was wondering.
And then plus, so H plus.
It's on the other page. You have it on the center.
Plus C, or the distance between here and here, right?
From the center to the foci is C.
From the center, yeah, and then A is the center to the vertex.
So this whole length right here.
Yeah, but they don't give us any numbers, so we don't have to worry about that right now.
Okay.
Alright, so I think we should do an example to explain this.
Okay. We gotta find anything for the other.
Alright, because I mean this is self-explanatory. We gotta need an example to do it. For an example. Right here.
No. Let me see.
Find the coordinates of the
Wait, does
center.
it say maybe where examples are? No.
Right here. But it gives you the numbers. They put in the numbers already.
That's the asymptotes.
What about right here? Because this is right after, so probably this will be the one.
No, they're saying find the coordinates of the center foci and vertices and the equations of the asymptotes of the graph.
But when I,
And this is the hyperbola. This
Okay.
is the graph of the hyperbola in standard form.
you would think that
Okay.
that would go with that, and this would go with the other one. So
But
it
we're
would be this
finding,
one.
we're just
This is an
basically,
example. These are notes.
This is an example too. So wouldn't these go together, and then this?
but we're doing the same thing we just did. We're just finding points instead of
But
standard
no,
form.
she's right. She's
She is right. This is later on. So,
So
Yeah. So we should
here,
use this
because here, but she's right. They're using
I agree.
the information that you learned here and seeing if you know it in example 1. So,
Alright, so,
we need to all do this example though.
okay. So it's saying, Haikika, if you look at example 1 on page 644, we're going to work through this using what we just learned on the table on page 643 at the very bottom. Alright, so first we need to find the points, correct? And then we can plug those into the equation. Alright, so first we've got the center, then the foci,
Yeah.
then the two vertices,
Hold on.
and then,
You know this on paper too.
wait, you know what? I got it.
No, I got it. No, there's a pencil. Use a pencil because you can write smart.
and then the transverse axis.
Okay.
Okay, so,
I'm okay with that. It's pretty simple.
alright, so they give us the two foci, which is -3, 1 for foci 1,
So it's 7, 1,
and
-3.
7, 1 for foci 2. Okay, so then we've got to find the center. So,
Wait, they give you the transverse axis. That's very important.
the transverse axis.
So that's this right here. So they tell you that that's 8 units long.
What is?
8 units long. This right here. This is the transverse axis.
Okay.
Remember? It goes
So
through the
then
vertices and passes through
The center, what was the equation to find the center? Remember?
Huh?
Equation to find the center.
Okay. Well,
Okay, a sketch of the graph is helpful. Let me the foci, let B and B2 be the vertices, and let C be the center. Okay, now it's
we have to
saying,
find the midpoint of this line.
Which
So we
is
have to
C.
use midpoint.
no,
C.
no,
For midpoint,
well,
you
yeah,
said
okay, from B2 to C, that's the midpoint. Well, that's half.
No, it's from
No,
foci
it's
to
from
foci.
here to here. So we have to go back in the book and find the
But they
midpoint.
just said midpoint.
It just said
That's why they
midpoint, the center. To locate center, find the midpoint of line F1 to F2. So we have to find the midpoint. So we need to know the midpoint.
formula. Okay. So, Jacob, you need a list of vocabulary. You need a list of vocabulary.
I mean, I can get the vocabulary off the book.
And don't forget about the midpoint one. So, here, do you want me to write that down?
No, it's alright.
Are you good?
Do you know what the midpoint formula is?
Just send me an email to remind me or something. Alright, so
Well,
we've got the two foci, -3, 1.
addition to vocab.
-3, 1, and 7, 1. So the midpoint formula, what is that?
Add
Pretend midpoint of a line segment.
Alright, x1 plus x2 divided by 2.
And then the same with the y's.
Okay.
Alright, that's cool.
Alright,
midpoint.
so x1 would be -3 plus 7 divided by 2. And then it would be For y, it would be 1 plus 1 divided by 2. So you've got...
The reason we're finding the midpoint is because we need the center.
Yes.
Okay.
Alright,
So say that for me.
it would be, the midpoint formula is
So
x1 plus x2 divided by 2 for the x value
say it. Why are we using the midpoint formula?
to find the center.
Oh, see to me, don't get it.
She can hear me?
Guys, quick
So, hi Kiko. To find the center, you have to use the midpoint formula, and you're using foci points, not vertice points, but foci points.
Well, the reason you're using the foci points
is because they give it to
they're
you.
given, yeah.
So
But if they give
the
you
vertex,
the vertices points, then you would use the vertices.
Yeah, exactly. So to find the y, it would be the same, y1 plus y2 divided by 2, and then whenever you plugged in your values, you would get 2, 1 for your y value. So the center is 2, 1.
So,
So now we have the h and k values, which we need to plug into.
So remember, our ultimate goal is to find to put the hyperbola into a standard form equation. So now we have our h and k, so we can plug that in.
Alright, so if you'll look back on page 643 in the table at the very bottom of the page, in the description column, you'll see what you need to plug in for which values. So we've got the center. So for the foci, so it's plus or minus c. That means that you'll have two different foci on two different x values, but you'll have the same y value. So you can go ahead and plug in the y value, which you know is 1. To find the x value, c is the distance from the midpoint to the foci, and they give you the line. They give you one of the foci, which we'll use -3, 1. Alright, so to find the distance from the foci, which is 2, 1, to the midpoint 7, 1, what would you do?
Oh,
Wait, what?
To find the distance from C to this foci, what would you do?
No, you wouldn't use the distance.
you would.
From this to this?
Yeah.
It's back right down.
How would you use that? Because you only have that line.
Yeah, but you have to also remember that this is 8. Here. You have that. Well, did you read the rest of this? It tells you right here. So you have, you know that C is 8.
No,
That
C
means
is
that
the
this-
midpoint, isn't it? Or C the...
I mean, well, this whole line, like your transverse axis is 8.
Yeah.
Which is, and remember, the transverse axis is always 2a. So if you just want a, then just divide it by 2, right? Because 2a equals 8.
And then
divided
A
by 2.
is the distance from the vertex to the
Exactly.
midpoint.
Because remember, here it shows you this is
Yeah.
from center to vertex. So from the center to the vertex, you have that. So this, that's just horrible. You know what? Forget it. This is A. Okay. So Hakika from the center to the from center to B1 is A. And then, so we know A equals 4. Now.
But we need to find it to the foci.
Huh?
We need to find the foci.
The foci. What are you talking?
We need to find the distance from this
We don't
to the
need,
foci.
no, we don't need that. To put it in a standard form, we have A, we need to find B.
We need to find C.
Why?
Because it's H plus or minus C. So you
But
need
it doesn't
C.
but it doesn't include the foci in this
But
formula.
you need these points, don't you?
Not to my knowledge. I mean, look at it here. No.
C is the distance from the center to the foci.
No, it's not. But yeah, that is.
It may not be in this formula, but why would she list it in this?
Let me see. Let me read through and see how they solve this.
You may not. Maybe you just need to find the center and then plug in all the other numbers. We got like 20 minutes.
Oh my gosh, are you kidding?
At least we're getting somewhere.
Have you guys finished your chemistry project?
That's why I can't do this today. The vocab today, so I can do that.
I'm almost finished. I just have to make a bumper sticker because I have to read my phone.
Use the equation B equal. Okay, so yeah, here I see where they're getting that. Okay.
So do you need C?
So here they don't directly use C. What they kind of do because B squared, they used the Pythagorean theorem. They basically shifted and said, well, B squared equals C squared minus C squared. So 25. Wait, where did I get 25?
What are you confused about?
Where did I get 25?
Because it's
C squared.
A squared. C squared. I mean, A squared, C squared.
What is?
So
Wait, hold on. Let me play. What's C again? Oh.
I told you you didn't see.
My bad. Chica was right. Okay, so basically C is the distance from the center to the to foci one.
Yeah, but you were right about Pythagorean theorem because with the transverse axis, you know that is it conjugative?
Conjugate.
Conjugate axis is perpendicular to it, therefore you can use Pythagorean theorem because it forms a 90-degree angle. It's a right triangle.
This is B, and then this is C.
Yeah, so to find B, all it is A. B equals A, right?
You can find C because you know the center and you know the foci point.
But if you're going to use Pythagorean theorem, like you said, you need to find this right here. You need to find the length of B.
You do, but that's why you move it around because you'll have the variable for A and A squared plus B squared equals C squared, and you'll have this right here. So you'll just subtract A to the other side. And then
B squared equals A squared.
Exactly. So when you plug in your formula, you plug in your formula.
I thought you could use.
I'm Charlotte Coast. I'm here with you tonight. Okay. You helped me last night, so yeah.
I thought you could use.
Oh yeah. So where are?
I thought since this is 4, you could say that this is 4 and it'll be an equilateral triangle.
No, not quite, because remember usually in for the Pythagorean theorem to work, you have to have a right triangle, and right triangles usually don't have like equal right here. Like for the Pythagorean theorem to work, like for it to come out evenly.
Okay, gotcha.
So you have A, which equals 4, and then C is what? C is 2.
Are you talking about the transverse axis?
This point, center, is at 2.
Yeah.
So you would say this is from 2, and this goes to 7. So 7 minus 2 equals 5.
Okay.
So that's where they got 5 from. So then they said A squared.
Mom was showing that to Hakiko. Mom was showing that to Hakiko.
Okay. Can you do it?
Yeah. Alright, Hakiko. So what Dylan said is if you'll look at the graph on page 644, at the very top on example 1.
Last night it goes right down to
Okay.
Okay, alright. No problem there. Solid TV, all right. Because my brain is, of course I teach math, so.
Alright, Donnie. So one foci, or IQ, sorry. One foci is at 7, 1. And we know that the center is at 2, 1. So from okay. Alright, we just gotta explain this. Alright, Delaney, so we know that the distance from C to the V, or are we trying to find from C to F or C to V?
Wait, for which one?
To find Pythagorean theorem. We're doing C to V, or C to F, okay.
Yeah,
So
but the
from,
reason that they use Pythagorean theorem is because you know that your, like this is a vertical line, so your x's will never change, but your y's will, but it doesn't matter. So you could take this point right here and draw a little diagonal line and say that this is C. Or you could just keep it down here and say that this is C. It does not matter. But visually, it helps you more if it's like diagonal, like this, so that you can visually see that it's like a triangle, and you will really use Pythagorean theorem.
okay, so Delaney, the way that this works out is you're trying to find the distance
From the center to foci 1.
from the center, this little hump right here. The
Yes.
distance from the foci to the center. So, so to do that, you use Pythagorean theorem, and you've already got the distance from the center to the foci.
From the center to the vertice, which is A, and then the point from the center to the foci is C. So what you're missing is that piece, like this, that's like a vertical line, like this, that's B. So if this is your triangle,
So, okay, I'm gonna do something at college. You take it to work.
so you have your vertice, foci, 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 okay? So you have your, let's just say this is your center, this is your conjugate axis, this is your transverse axis. You find your point from your center to your vertice, which is A. So you have A. Then you can't find B because you don't know your conjugate axis. But you can find the distance from A to your vertice. To your foci. So it should be C. Okay? So you find C, you find A, so you're left with B. And then you can use the Pythagorean theorem, which is A squared plus B squared equals C squared to find C. To find B.
There's a reflection.
To find B. So you would move A over to the other side, and you have B squared equals C squared minus A squared. And that will be what you find.
Alright, so that's all the time we got for today.
Okay, yeah, we're gonna go ask Miss Lynn some questions, but we'll email you tonight and tell you what we asked about. Okay, bye.